So in the previous chapter you studied relations and functions. In that relations and functions you studied one more important thing, inverse of a function. Yes or no? So inverse of a function. So inverse of a function of x, it is denoted by what? F inverse. So inverse of a function, it is f, then f inverse is what? The function. So when we are saying it is a f inverse, if f is 1 1 and onto. If f is 1 1 and onto, so we can find the inverse of the function. Okay, so this inverse trigonometric function, so we are applying this inverse function in the trigonometry. So you know that in the trigonometry you all studied the sine theta, cos theta, tan theta, cot theta, secant theta and cosecant theta. In that range and domain also you studied in the first year PUC. So here in this inverse trigonometric function is a very important role in the calculus part. And the calculus part means differentiation and integration. You will study it in the next part of this second year. Okay, so in the engineering purpose also we are studying this inverse trigonometric function. So inverse trigonometric function is a very important. Okay, so now in the last year you studied about the sine function. So in the sine function it's what? R is tends to minus 1 comma 1. So this is what the closed interval means, minus 1 and 1 is also including. Then cosine function, the same thing, cosine function and cosine function is range is same, r is same. Okay, so now the tangent for this r is minus 2n plus 1 into pi by 2, n is belongs to z. So minus all the real numbers but minus of this. Okay, then this tends to what? R. Next cotangent function is a cot. So minus x equals to n pi. Yes, n is belongs to z. Okay, this minus all the real numbers but minus n pi. Okay, so now secant function, it is a r minus 2n plus 1 then pi by 2. Then the r is also what? Minus of minus 1 and 1. So you know these the things we are studying in the first year. Okay, domain and range you have studied. Okay, so now here we have to take that domain and range. So for example, y equals to the function, it is what? F from x to y, such that f of x is 1 1 and onto. F from x to y such that f of x equals to y is 1 1 and onto. Then we can define a unique function. Then you can define a unique function g from y to x. So this is what? Inverse f from x to y and g from y to x. So such that g of y equals to x, where x is belongs to x and y equals to f of x means y is belongs to y. So the domain of g is range of f. So what is the range we are getting? No, that is what? The domain of g. Okay, so the domain of g, this is very important. Domain of g is equals to range of f, and range of g is domain of f. This is ulta reverse process. Okay, so the function g is called a inverse of f. So that this function g is called as, no, this is inverse of f. Okay, so it is called inverse of x, is denoted by f inverse. So further, g is also 1 1 and onto, and inverse of g is f. Okay, it means g inverse is equals to f inverse of inverse equals to f. That's why g is f. Okay, so these are the things you know that. Now in the domain of the sine function, the set of all real numbers. Domain of the sine function is set of all the real numbers. All the real numbers are domain of the sine function. And what about this range? So what are the values you can take as a domain? The range, it should be minus 1 and 1. It lies between minus 1 and 1. So you know that therefore the restrict its domain is minus pi by 2 to pi by 2. So in the graphical representation, you know that minus pi by 2 to pi by 2, it becomes 1 1 and onto with the range minus 1 and 1. So actually the sine function restricted to any of the intervals any of the intervals. Sine function, it has the value of 270 degrees, sine 90 degrees, sine 180 degree, sine 0 degree, sine 360 degree, all the values we have, no? So that the interval becomes minus 3 pi by 2 to pi by 2, and minus 5 pi by 2 to 5 pi by 2, then pi by 2 to 3 pi by 2, etc. like this. So is 1 and its range is what? So whatever the values you can take this one, the range it should be minus 1 and 1. So we can identify this inverse sine function of these intervals. We can take it as sine inverse. Sine inverse. Okay, so sine to the power of minus 1 is a function. It is sine inverse is a function whose domain is minus 1 and 1. But in the previous one, the range is minus 1 and 1. In the sine function, the range is minus 1 and 1. The domain is minus pi by 2 to pi by 2. But in the inverse function, domain is minus 1 and 1. The range is could be the lies between the branch with the range minus pi by 2 to pi by 2. Why? Minus pi by 2 and pi by 2 is a common. Minus 3 pi by 2, minus pi by 2, minus pi by 2, pi by 2, or pi by 2 to 3 pi by 2. Okay, so that the principal range branch which becomes branch with the range, it is minus pi by 2 to pi by 2. This is called as the principal value branch. This is called as what? Principal value branch. Therefore, the sine inverse can be written as domain is sine inverse can be written as the domain is minus 1 to 1, and this range is minus pi by 2 to pi by 2. But in that case, sine function we are written as r tends to minus 1 to minus 1 to 1, but here it is tends to minus pi by 2 to pi by 2. Okay, this is our inverse. So now in this graph you can see this one is already you learned in the previous year, last year, y equals to sine x. So y equals to sine x is the function, the value of sine 0 is 0, then sine pi by 2 is 1, and minus pi by 2 is minus 1, like this, you know that value. So that value is not goes beyond that 1 and not goes beyond the minus 1. So values, it should be minus 1 and 1. That's why that is our range. Then what are the domain? You can take it as pi by 2, minus pi by 2, minus pi, 3 pi by 2. Then this all the terms what we can take it. This is a what? The values comes under only that these things. Okay. So now in this year, this is what y equals to sine inverse of x. So sine inverse of x means we have to take that value as 1 when we are getting this. So pi by 2. And then minus pi by 2 is minus 1. So the value is does not not more than minus 1 and 1. So that's why, so which is the value is satisfying. One is minus pi by 2 and pi by 2. So both the functions we can write like this. So this is the x value, this is the x-axis, it will comes like this. This graph we can fix it here, and this graph we can fix it here. So the graph is comes like this. Okay, so this is belongs to what? The plus 1 and minus 1 and minus pi by 2 and minus pi by 2. So this is our shaded part is there here. This is belongs to what? Sine inverse x. So now in the similarly the cosine function. So in that cosine function, domain is set of all the real numbers. Domain is set of all the real numbers. In that time, what is the range we are getting? The range it should be minus 1 and 1. The range it should be what? Minus 1 and 1. But this is applies only in that 1 and onto function. With the range it is minus 1 and 1. So that inverse of that cosine function, it's a intervals. Which are the intervals we may get? Minus pi to 0 and 0 to pi, pi to 2 pi, etc. Right? So it is about bijective with the range as minus 1 and 1. Now if you want to convert this one into that inverse of the cosine function, it is cos inverse. Cos inverse, here what is the range that goes to a domain. Okay, so when we are taking this value, then which are the values are satisfying? So these are the range. So these are the range means when the value is minus 1 and 1, we are getting only that branch sign is 0 and pi. 0 and pi. So this is called as the principal value branch. so that we can write in the sine inverse it is minus 1 1 tends to minus pi by 2 to pi by 2, but here it is in the cos inverse we can write minus 1 comma 1 to 0 comma pi. Okay, so exactly reverse of the cosine. Exactly reverse of the cosine means in that cosine this is the domain and this is the range. This is what cos inverse, this is the range and this is what domain. Okay, so that is the things we have to consider it. Now for this graph we are getting the same thing, y equals to cos inverse x, the values it should be 1 to minus 1, so this 0 to pi only, 0 to pi. So here it is a minus pi means minus 1. So y equals to cos x and y equals to cos inverse of x. This is the last year you studied and this is what new this year. So value is from which to which? 0 to pi is the principal value range and that value domain is what? Minus 1 to 1. So next that reciprocals we can write. The reciprocal of sine and cos is cosecant and secant. Okay, so cosecant and secant. Similarly we can write the cosecant is r minus of minus 1 and 1, r minus. So here in this minus 1 and 1 is not including, minus 1 and 1 is not including, then all the real numbers. Okay, then this becomes what? Minus pi by 2 to pi by 2, that is what? Same. Okay, now in the secant also it is the same thing. So here 1 and minus 1 is not including in that secant inverse and pi by 2 is not including. Okay, so secant inverse r minus of minus 1 to 1 and tends to 0 to pi, so minus pi by 2. This is the principal value branch. This is what? Principal value branch for the secant inverse. So minus pi by 2 is not there. And then cot and tan and cot. So you know that tan function it is same as that what is that function, all that minus pi by 2 to it says infinity, it means all the range real numbers it is there. So r to minus pi by 2 to pi by 2. And then cot is also a same thing, we can write it is 0 to pi, r is tends to 0 to pi. So clearly we can understand by seeing this chart. So this chart is a very important. This is what domain and this is what range. Okay, so sine inverse minus 1 and 1 is the domain and minus pi by 2 to pi by 2 is the range. So here in this chart one question is comes under the 1 marks side, part A. Write the principal value or range or principal value branch or domain they are asking. Okay, so cos inverse for the cos inverse domain is r minus of minus 1 and 1 and this is what? Minus pi by 2 to pi by 2, but 0 is not including in that. Okay, now secant inverse is r minus of minus 1 and 1. Here minus pi by 2 is not including. In the tan inverse domain is r and range is minus pi by 2 to 2. Okay, then cot inverse is domain is r and range is 0 comma pi. So this table is a very important table for the exam. Okay, so 1 marks, 1 question will be there in from this table. Now I'll move to the exercise part. Exercise question exercise 2.1. First question I will take now. So here you know that all the domain and all the ranges. Then now we have to find the principal value. So principal value of that exercise number 1, the first question, it is sine inverse of minus 1 by 2. Okay, so sine inverse of minus 1 by 2, it can be written as sine inverse of minus 1 by 2, I will take it as y. Okay, so now sine y equals to what I can write? Sine I equals to minus 1 divided by 2 I can write. So sine y equals to minus 1 divided by 2. So minus 1 divided by 2 means, so what is the value? Sine which degree is minus 1 by 2? So it is what? Sine of which one? Pi by 4 or pi by 6 or pi by 3. It is what? Pi by 6. Okay, so pi by 6. It means now, so what is the value we are satisfying? This is what sine of pi by 6. Okay, so sine of pi by 6 means what is the principal value? That value range is what becomes which and which? Minus pi by 2 to minus pi by 2 to pi by 2. So that answer is, what is the answer we are getting? Minus is here. So sine inverse of minus 1 divided by 2 is minus pi by 6. Or also it can be written in the other form. Here it is what sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2 can be written as minus sine inverse of 1 by 2 we can write. Minus sine inverse of 1 by 2. So minus sine inverse of 1 by 2 is sine inverse. 1 by 2 can be written as sine pi by 6. So now sine inverse and sine get cancelled. So answer is minus pi by 6. This is another one way and this is one more way. Okay, the answer is minus pi by 6. So now next one is second one, cos inverse root 3 by 2. So this is very simple. Cos inverse root 3 by 2 can be written as cos pi by 6 or not. Cos pi by 6. So cos pi by 6. Cos inverse of cos pi by 6 means the cos inverse and cos comes means we can write only that pi by 6. So in the small simple value you can write cos of cos inverse of x, that value is x, and cos inverse of cos x equals to what? X. So all the same functions, sine of sine inverse of x is x, sine inverse of sine x is x. So same way we can write the directly answer is like this. Now cosecant inverse of 2. So cosecant inverse of 2 means cosecant inverse of 2. So cosecant inverse of 2, what is the value when we are getting the 2? So cosec pi by 6. Cosec pi by 6. Cosecant inverse and cosecant is cancelled. So what is remaining? Pi by 6 is the answer. So now next is tan inverse of minus root 3. So tan inverse of minus root 3 is there. So this is one of the term. Minus we can take it outside. Tan inverse of root 3 we will get. So this becomes minus tan inverse of root 3. Root 3 value is tan pi by 3. Root 3 value is tan pi by 3. So you should know these values. Last year you studied all these values. So you have to remember all the values. So tan inverse of tan pi by 3, it is what? Pi by 3 is root 3 value. It becomes minus pi by 3. Okay, clear? So now next, now this is one of the important type, cos inverse of minus 1 by 2. So cos inverse of minus 1 by 2 means if you want to take that values in the first year you studied, cos of minus theta is pi minus theta we have to take. Cos sine of minus theta is minus sine theta we can write, but cos of minus theta is pi minus cos theta we are writing. No, the same way here it is pi minus cos inverse of 1 by 2. You should remember this. Okay, so now cos pi minus cos inverse of 1 by 2. Cos 1 by 2, 1 by 2 value is cos pi by 3. So it becomes pi minus pi by 3. Okay, so cos inverse of cos is what? Pi by 3. Pi is outside, it is there. Pi outside means 3 pi minus pi by 3. It is equal to what? 2 pi by 3. So what is the answer? 2 pi by 3. Okay, now next tan inverse of 1. Tan inverse of minus 1, tan inverse of minus 1. So tan inverse of minus 1 means tan is there means minus tan inverse of 1 we can write. So minus tan inverse of tan. So 1 value, when we are getting 1, tan pi by 4 or 45 degree, no? It is what? Minus pi by 4. That is minus pi by 4. So next question, it is 7th one. Secant inverse of 2 by root 3. So secant inverse of 2 by root 3, there is no minus and there is no plus sign. So plus sign only it is there. So directly we can write secant inverse of secant. Secant which degree is 2 by 3. Secant pi by 6. Pi by 6. Okay, so secant inverse of secant pi by 6 is 2 pi by 3. So the table is very important for you. The answer is pi by 6 is the final principal value. Now next, cot inverse, you can check the same way. Similarly, you have to check cot inverse. Cot inverse, that is a work for you. So now next I will explain it is what cos inverse of minus 1 by root 2. So once again it is what cos. So pi minus cos inverse of 1 by root 2 we have to write. Pi minus cos inverse of 1 by root 2 is cos 45 degree. It means cos pi by 4. Okay, so pi minus pi by 4 we are getting. So the answer is 3 pi by 4. Okay, so principal value branch is 3 pi by 4. Next, one more last one is cosec inverse of minus root 2. So cosec inverse of minus root 2 is comes means we are getting the same one, minus we are take it outside. So minus we want to take it outside, it is cosec inverse of root 2. So now minus cosec inverse of root 2 is cosec which degree? Cosec pi by 4, 45 degree. Cosec pi by 4, it is what? Minus pi by 4. So I hope that all the 10 questions are easy and you can understand very easy way. Okay, so now I will simplify the next part. It is find the value of the following. So we have to find the value of the questions. So first one, it is 11th one I am taking now. Tan inverse of 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. So this is also one of the important type question. Clear? So now how to find this? Tan inverse of 1 and cos inverse of 1 by 2. So tan inverse of 1. So tan inverse of tan pi by 4 we can write. Clear? Plus cos inverse of minus is there, pi minus cos inverse of cos 1 by 2. When you are getting that 1 by 2 cos, so you have to tell now 1 by 2 is pi by 3, no? Pi by 3. Okay, now plus and minus outside is there, so minus sine inverse of sine 1 by 2. When you are getting sine 1 by 2 value, it is pi by 6. Pi by 6. Now this becomes pi by 4 plus pi minus pi by 3 minus pi by 6. So now take the LCM. LCM is, so what is the LCM for this 4, 3 and 12? It is 12. 6, 12 is the LCM. So what is the answer we are getting? 12 means 3 pi plus 12 pi minus 4 pi minus 2 pi. So what is the answer? So 12 plus 3 is 15. 15 minus 4 is 11. 11 minus 2 is 9. 9 pi by 12. So 9 pi by 12 means 3 pi by 4. So the last final answer is how much now? 3 pi by 4. Okay, so now 12th one we can simplify it now. Cos inverse of 1 by 2 plus 2 sine inverse of 1 by 2. So now cos inverse of 1 by 2 means cos inverse of cos which value? Cos pi by 1 by 2 means cos pi by 3, right? Cos pi by 3 plus 2 into sine inverse of sine pi by 6. Sine pi by 6. Cos inverse of cos, it is pi by 3 plus 2 into pi by 6. So 2 1s are 2 3s are. So answer is 2 pi by 3. So this answer is what? 2 pi by 3. So I hope that all of you clear now. Okay. So now next 13th one, it is value, multiple choice questions. You have to check, you will get the answer. And 14th one is also same thing, tan inverse of root 3 minus secant inverse of minus 2. So secant inverse and cos inverse of any minus term comes means you have to take it pi minus. cos inverse of minus x is also what? Pi minus cos inverse of x. And secant inverse of minus x is pi minus secant inverse of x. And cot inverse of minus x comes means pi minus cot inverse of x. So you have to remember. So only that these cases you should remember what is that? Pi minus. Which are the cases? So remember, cos inverse of minus x equals to what? Pi minus cos inverse of x. Secant inverse of minus x is equals to pi minus secant inverse of x. And cot inverse of minus x equals to pi minus cot inverse of x. So in these three cases you should get pi minus. Otherwise in all the cases we have to consider only that instead of this one sine inverse of minus x means minus sine x we are writing. Okay, so these are the properties we will study. So in the next class I will explain the properties of inverse trigonometric functions.